Very happy to see you guys. I hope you guys are having a great day. Okay, we're going to learn about surface tension today. Do you guys have the coins or no? The coin?
No.
It's okay. It's okay. You guys can watch me do it today. I have two experiments, okay? One with water and a paper clip, okay? That'll be after the lesson. And also one with a coin, okay? So I'm going to show you guys each afterwards. But yeah, we're going to learn about surface tension and water. We're going to learn about the properties of water and the bonds on the atomic level, the bonds of water. Okay? So I'm going to share my screen here. Can you guys see? Let's see. Okay. So here is the first slide. Why is water important? Okay. So you guys all know what water is. Okay, we drink it. This is water here. And today we're going to be learning about the atomic level of water. What's inside of here and how the properties of water prove our experiments that we're going to do later. So here is the importance of water. So all of our cells in our body are surrounded by water. The example is blood in our body. Cells are made of 70% to 95% of water, and 3/4 of the earth is made of water. So water, as you guys know, is very, very important. Without water, we wouldn't be here, and it's all around us. It's in all the living plants, all living beings, or at least mostly all living beings. And it's important in the sustainability of life, okay? We need water to grow. We need water for hydration, especially our cells in our body. They need water, okay? And they use water. And yeah, so that's the importance of it. The structure of water. Okay, so I don't know if you guys have learned about chemistry before, but chemistry has a lot to do with the experiments that we're going to do with the water bottle and the coin. Chemistry has to do a lot with the structure of water and how it's formed, what type of bonds are inside of water, how the atoms and the molecules of hydrogen and oxygen combine and form bonds. Okay, we're going to learn about that later on in the lesson. It probably won't be too long of a lesson, again, but it is a very important one, and the experiments are pretty cool. So what is the chemical formula of water? H2O. Okay, so H2O is the chemical formula. And H2O represents how many molecules of each element is inside of water, okay? So, as the name suggests, H stands for hydrogen, and O stands for oxygen, okay? So I'm going to draw out a representation and show it to you guys of what exactly it's meaning. Okay, so you have two hydrogen atoms in a molecule of water, okay? In one molecule of water, there are two hydrogen atoms, okay? I don't know if it's reversed, but you have two hydrogens right here and one oxygen, okay? So it's H2 for two hydrogens, and O has a subscript of 1. So that's the chemical formula. It's going to make sense as we move on. And those are how many atoms of the elements are inside of one molecule of water. So how many atoms of hydrogen are there in water? 2. 2 hydrogen in one molecule of water. How many atoms of oxygen is there in water? There's 1 molecule of oxygen. So hydrogen and oxygen are both gases. They're both gases and they are around us. Oxygen especially is in the air that we breathe, and we need oxygen for our lungs, for our respiratory system. Oxygen fills our blood and it oxygenates our bodies so that we can breathe and provide oxygen for our muscles and for our blood. Anyways, that's the makeup of those two gases. So here's a periodic table, okay? This table has all of the elements. It has every single element that is man-made, or sorry, that is natural, and then some that are man-made, which are at the bottom. And the only ones that we're going to be focusing on today is element 1 and element 8, number 8, okay? So number 1 is hydrogen, top left. It has the letter H, okay? So look for the letter H, and then look for the letter O. So you have H is number 1, and then oxygen, which is the letter O, it's number 8, okay? This is where they stand on the periodic table, and maybe in a future lesson we can learn more about chemistry, which is one of my favorite subjects. However, the physical makeup of these two atoms of hydrogen and oxygen, they're both gases. And they both have properties of gases. They are not solids at room temperature. Okay, so when they're combined, when they form these bonds that we're going to learn about in a second, when hydrogen and oxygen combine, 2 hydrogen, 1 oxygen, they form water. Okay, they form water. So top left, remember they're both gases, so it's kind of neat to think about how 2 gases can actually make a liquid. But that's the beauty of nature and chemistry. Anyways, we're going to learn about that further going forward. So what makes water so important? And the answer to this, it's very simple. You guys can see right there, because of its structure, okay? The structure and the properties are extremely important in why water is so important. So covalent bonding, that is the type of bond that forms water. And it's a polar, it represents polarity within the atoms. Okay, we're going to learn about that in a second. And also hydrogen bonding. So before we get into those, we have to learn about the 2 types of bonding. Okay, so if we go back to the periodic table, every single element, obviously it has a state of matter. So either solid, liquid, or gas at room temperature. Okay, it's either solid, liquid, gas, or room temperature. And all of these can form bonds. Okay, there's 2 types of bonds, at least from what we're going to learn in this introduction to the properties of water. So we have covalent bonds, okay, covalent bonding, and we have ionic bonding. And ionic bonding is with a metal and a non-metal. And remember, hydrogen and oxygen are gases, they're not metals, so they're non-metals, and they form what is called a covalent bond. And they form these covalent bonds between 2 gases, okay, it's 2 different gases, hydrogen and oxygen, and they form these bonds through what is called covalent bonding, okay, covalent bonding, and they form them through the electrostatic differences in the charge of their electrons on the outer ring of the atom. And we're going to look at a picture shortly to represent that. And also, what's important about water is that there are hydrogen bonds inside of water. That's what gives it the surface tension. So the whole point of this lesson is we're going to learn about the surface tension on the surface of water, okay? And how strong it really is for the amount that you use it. So in our experiment, okay, we're going to see how the water doesn't fall off of the coin and how the paper clip doesn't sink, all because of the hydrogen bonds, okay? Hydrogen bonding, it's not like covalent bonding. It is a type of bond, but it's between the different water molecules. There are hydrogens bonding to each other through cohesion, and it is forming a very strong and tightly packed surface so that the surface will not break or crack. Okay, so here is a picture of H2O. Okay, remember the chemical formula of water, H2O. Okay, H2O. That's a picture of H2O. You have the two hydrogens on the outside, and then you have the one oxygen in the middle. And covalent bonding, what's really cool about that is that it's the sharing of electrons on the outer ring of the atom. Okay? Every atom has a ring around it. Some atoms have multiple rings, and some atoms only have one ring, like hydrogen. See, hydrogen only has one ring, and oxygen has two rings. On the outer layer of that ring, remember yesterday we learned about the electrons on the outer surface of our bodies through static electricity? It's somewhat related, okay? But the electrons are actually shared between the hydrogen and the oxygen. So they form a bond. The hydrogen is positively charged and the oxygen is negatively charged. So remember yesterday we learned about static electricity and how positive and negative attract, okay? So if hydrogen is positive and oxygen is negative, that means they're going to form a bond and they're going to make water. They're going to make one molecule of water, okay? And that is how covalent bonds work, especially in this case with oxygen. Polar covalent bonds, which means polar means that there's a difference in charges forming polarity between the two. Covalent bonding, sharing of electrons. So this is exactly what I was talking about. You have the hydrogen, which has one electron on its outer ring, and you have oxygen, which has 6 electrons on its outer ring. The hydrogen connects with the oxygen to form 8 electrons on its outer ring, forming a stable molecule. Okay, all molecules want to be stable, and that is how they become stable, is by forming bonds, either ionic bonds through a metal and a nonmetal, or a covalent bond. Okay, so look at the picture. You have oxygen in the center. Oxygen is a gas, remember. Oxygen is a gas. Hydrogen is a gas. And they form bonds by sharing, okay? They share the electrons between each other. So every element, if we look back at the periodic table, every element has a certain amount of electrons, which are negatively charged particles, on its outer ring, on its outer shell, okay? And these electrons can have different charges, like with hydrogen, it's positively charged particles, and then oxygen has negatively charged particles. And like I said, they combine through polarity, and they are covalent because they're both gases. They're not a metal and a non-metal. Okay, so we can determine how many electrons are in the outer ring by looking at the numbers at the top. So all those numbers at the top, 1, 2, 3, 4, 5, 6, 7, it goes all the way to 18. You can tell how many electrons they have by taking the first number here, and then once you get into the single digits, you take the second number after the 1. You just drop the 1. That's all you do. You take away the 1, and it tells you how many electrons are in the outer shell. So for instance, oxygen is in group 16, okay? So oxygen is in group 16. If you take off the 1, you get 6, okay? You get the number 6. That means there are 6 electrons on the outer shell of an atom of hydrogen, of a molecule of, a molecule of hydrogen, atom of hydrogen, just like that. So that's a quick way to find how many electrons are on the outer shell, which is, that's a different lesson. Don't worry about that. It's kind of more into chemistry, but today we're just doing an introduction. So here is the polar covalent bond, okay? So there's 2 types of covalent bonds. There's polar and non-polar, okay? Polar covalent bonds is with different types of charges between 2 non-metals. Okay, so hydrogen is a gas, oxygen is a gas. They share because one is positive, one is negative. A non-polar covalent bond is usually either with the same element, forming bonds between itself, or with different elements of the same charge, okay? And they form bonds that way, but it's mainly with the same element. So yeah, there's polar covalent bonds. Just remember the lesson from yesterday. It's very, very simple. One's positive with a plus, and one's negative. So positive and negative attract, okay? The plus and the minus. Polar molecule. Okay, so this is exactly what the last slide was talking about. Reading from it here, it says that it's a molecule in which opposite ends have opposite electric charges. Electrons spend more time with oxygen than hydrogen, okay? Hydrogens become slightly positive and oxygens slightly negative. So remember, hydrogen is always going to be positively charged, and oxygen is always going to be negatively charged because it's on the right side of the periodic table, okay, for the most part. That's how you determine the charges of different elements, okay? That's also another lesson for another day. But just remember for water, okay? Just remember for water, you have hydrogen that's positive and oxygen that's negative. They form electrostatic attraction. Not electrostatic attraction, but the different charges form attraction. Okay. Properties of water. So here are the different properties of water. So it's a solvent, okay? So solvent means that it can dissolve something. So I don't have anything that's dissolvable on me right now, but if I were to put salt, okay? If I were to put salt in this water, it would dissolve the salt. The salt would be dissolved inside of the water. And this is because it's polar, and polar dissolves polar, non-polar dissolves non-polar. Okay, so water, like it says, can dissolve almost all substances or any type of polar molecule. Anything that has opposite charges, a positive and a negative, can be dissolved by water. So what being dissolved means is that the water can actually break down that substance. The water can break down the substance if I poured salt or sugar or whatever it is, and it would completely break down the substance and combine physically with the water. Not chemically, but physically, it would be combined. Okay. Water cannot dissolve oil. It can't dissolve butter, petrol, or gasoline. Those are non-polar. Okay. And non-polar cannot be dissolved by a polar solvent or solute. Yes, I think it's solute. No, solvent. Non-polar solutes cannot be dissolved by polar solvents. Okay. Only polar solutes can be dissolved by polar solvents. And all a solvent is it's something that can dissolve another substance. So a solvent, in this case, is water. Water is a solvent. Okay, it's one of the main ones out there. And a solute is something that can be dissolved, like salt. Salt is a solute. Okay, it's any substance that can be dissolved either by water or another solvent. Solution. So look, this is what I was saying. Water is dissolving the sugar. Okay, you have the solute, which is the one being dissolved, and you have a solvent, which is the one that's doing the dissolving. It's always greater in amount, and it's dissolving the substance. For example, salt or sugar. Okay, so here is a picture of salt being added to water, and the water is dissolving it, just like in this picture. Cohesion. So this is the second property of water. Okay, cohesion is very important in talking about surface tension. Okay, and cohesion is the attractive forces between water molecules. So remember, hydrogen bonding is between the different molecules, okay, through cohesion and through the hydrogens forming bonds with each other. The water molecules stick together, and this is due to hydrogen bonds, just like I was saying before, okay? The two hydrogens, plus and plus, you may think they would repel as far as the electrostatic lesson goes that we learned yesterday. However, inside of water, since you have oxygen, which is negative, to give the balance, there is cohesive forces being formed with hydrogen bonds, and that's called cohesion. Okay, is the attraction between two like molecules. Okay, here's a perfect picture to represent that. So cohesion and adhesion is what's happening here. So the oxygen, you can see, is forming a bond together since it has the hydrogen with it, and that's called cohesion. Remember, the hydrogen bonds are very strong, okay? And whenever you have two of the same molecules forming a bond with each other, not like H2O, but the entire molecule. So H2O and another H2O. When you have two H2Os forming a bond, that's called cohesion. And that is what gives water its very strong surface tension. Okay? Adhesion is the second type of attractive force that can be formed. Okay, so that's with polar or charged objects. And adhesion, I don't know if I have a picture here to represent it. I don't, but adhesion is with another object. Is the attraction with another object that's polar, that's charged. Okay, that's polar. So the third property of water, this one's very important, It's surface tension, okay? See the paper clip on the top? This one here? You can see it in the picture. We're going to do an experiment on that after this lesson, and I'm going to show you how to make it float on the top. So cohesion of water molecules at the surface of a body of water. So remember, hydrogen bonds through cohesion and the water molecules form a very, very strong, you can't separate it. It's very strong force at the top of the water, okay? And it's all throughout this water. Those bonds are all throughout this water. And that is what gives water its very high surface tension. And surface tension is basically the, just like it says, it's the tension before the molecules break on the surface of a liquid, okay? In this case, yes, with the water. So here is a quick video to explain. It's a little confusing to understand, but I just want you guys to listen to it, and if you can see it, watch it, okay? He's going to explain what surface tension is, okay? So remember what we talked about. We have hydrogen and oxygen, positive and negative, they form bonds to form one molecule of water. Then, after you have one molecule of water, you have H2O and H2O, and they form water through cohesion, and they form bonds with each other, okay? And there are hundreds, thousands, and millions of those molecules inside of this glass of water here, okay? So let's watch this video. So look, the surface of water, the surface, that line right there is all, remember, different molecules of water forming together a bond through intermolecular forces and cohesion through hydrogen bonds to form a very strong surface, like our skin. See, like our skin, okay? It's the same concept, but with water. Okay, let's continue watching. Okay, so that's the video there. And it was a little, he went a lot very in depth with the explanation. He was very very in depth, but that is a quick video to represent how surface tension works. Okay, so remember you have the hydrogen bondings with the two hydrogens that form in H2O. They bond with other oxygens through what's called hydrogen bonding. You have the positive and the negative charge, very strong, okay? And that is on the surface of the water. So then you have adhesion, the attractive force between water molecules and other molecules due to hydrogen bonds, okay? And capillary action, it's the upward movement of water in small tubes due to cohesion and adhesion, okay? So remember, if we look back at our picture, cohesion is two water molecules coming together, and adhesion is the water forming bonds with the surface and with the other objects that it is around, okay? And capillary action is very important and very relevant in the world around us. So especially in plants and all the food that we eat that comes from plants, there is capillary action that's taking place. So if we look at a plant, I don't know if I have a picture here. Yeah, I do. The stem of a plant, okay, the stem of a plant carries the water from the soil through capillary action. Okay, the water through cohesion, through adhesion, not cohesion. The water through adhesion and the attraction to the surface of the stem climbs up the stem, just like that, and it goes out to the leaves of the plant. You can see here, adhesion, it's connecting to the stem, the wall of the stem, and it's going up to go to the leaves, okay? We have a second video here, but before I start it, I need to make a new meeting because I'm almost gonna run out of time. So Janisa, is Janisa here or no? No, she's not here? Can you tell Janisa we have to make a new meeting? Janisa, hi.
Hello.
Hi. Anyways, here is a summary of what we learned, okay? So the 5 properties of water, okay? We have the first property that talks about water dissolving different substances, okay? Like salt or sugar. The second property is that there are bonds that form through cohesion with the different elements of oxygen and hydrogen, okay? So each molecule of water bonds to another through hydrogen bonds that form through opposite charges of a positively charged hydrogen and a negatively charged oxygen. Surface tension is the third property. We're going to learn about that today. After this, we're going to do the experiment. And adhesion, which is the other force that is formed with, in this case, water molecules, where the molecule is attracted to an opposite object with polarity, with a different charge. For example, in the stem of a plant. So the water travels up the stem. The water travels up the stem through adhesion, which it's attracted to the opposite object, the stem, the surrounding, the surrounding area. Okay, and then capillary action, which is exactly what number 4 is explaining. It's adhesion with the opposite object. Okay, so that's it. That's all the lesson is for today. Now we're going to do the experiment. If you guys don't have the coin, it's okay. I'm going to have you guys watch me. So let me move this desk because I want you guys to see. So, hey, please.
Yeah.
Yeah, you want to say hi? Come here. This is my mom.
Come on. I said hi, bro. Hi.
Hello.
Say hi. Love you. Bye-bye. Okay. So, we're going to do the experiment here. Mom, can you shut my door? Yeah. Okay. Mom, oh. That's my dog. That's my doggy. All right. Thank you, Mom. Okay. All right. We're going to do a demonstration here with a paper clip and water. Okay, so we have 2 paper clips and then we have water. I want you guys to see this. Okay. So if I take the paper clip, like this and drop it in the water, it's going to sink. It's going to fall to the bottom. So look, watch. Okay, it sinks. It's at the bottom. However, if I put a paper towel on the top, like this, paper towel on top. Hold on. Give me 1 second. I want to get a clean paper towel here. If I put a paper towel on the top of the water, I don't know if you guys can see here, but hold on. Give me 1 second. I have to lay it down very gently here. Okay, so if I have the paper towel here and I let it sink, push it down. The paper clip is going to start floating at the top. And that is the floating paper clip at the top. I don't know if you can see. Let me take my camera here. You can see it's floating here at the top.
Yes.
Okay.
Okay.
And that is the surface tension. So the hydrogen bonds on the surface of the water create a very tight surface. And then you have the paper clip at the bottom. So there it goes, it's floating. And then if I tap it in the center, it's going to break the bonds. Okay, I'm going to lay it down on my desk here. And it already fell. So the paper clip was floating at the top, you guys saw, and the surface of the water. So the surface, remember, it has the bonds. It's very strong. So the paper clip wasn't going to fall because the hydrogen bonds of the molecules formed at the top. Okay. So the second experiment, we have a coin. Okay. I'm going to take my camera here. I'm going to place it on my desk like that. Okay. You guys see the coin? And I have my dropper here. Okay. So we're gonna put little paper towel here. Okay, now watch the coin. I have water. Now the water is not falling off the side of the coin, okay? It's staying on the top. It's staying on the top, and it's forming a circle, a spherical shape, okay?
Oh, nabasa na ganun. Bawoy. Ayo. Balgin.
So I can continue to add water droplets, and it's going to continue to branch out on the sides, okay? So it's not falling off the coin, it's staying on top because the bonds of the hydrogen and oxygen on the surface of the water is very strong. It's very strong. So they form very tight bonds together, and it's not going to spill. Now, if I poke it with a pencil or add some more water, the bonds will eventually break because it can't sustain the weight. Just like that. See? No more water because the bonds were too much, or not the bonds, but the force and the weight of the water was too much for the bonds to keep tight and hold. Okay, so those were the two experiments. Let me see here, get my camera back. Those were the two different ones. We have, remember, the paper clip on the water, and then we have the coin and the dropping of the water on the top. So that is surface tension, okay? Very easy, simple lesson. Remember, we have H2O is the chemical formula name. One hydrogen, positive, and two hydrogens, positive, and one oxygen, negatively charged. They form a bond, and that is how water is created, and those molecules have cohesion with each other, and they form a very strong surface tension. Okay, that's it. That's the lesson. Thank you guys. Are you guys doing good? Everything is good? Did you learn? Did you guys learn something cool? Good, good. Happy to see you all. Okay, are you guys excited for the rest of the summer?
Yes.
Good, good. All right. Well, I don't know if I told you guys, but I'm turning these into videos, okay? So to post online so you guys can go watch them if you want, okay? And you can look back on the lessons and you guys can see the different types of things that we're going to learn. This is going to be our last meeting for July or for June. Arlene told me that in July you guys, I think, go away or something like that. So we're going to start again in August. So I won't see you guys for another month. But once we start again, I'm going to have my school start to do the lessons, and I'm going to have other people here too. And we're going to make it bigger. And maybe eventually one day we can all plan a trip over here and come and visit you guys. Okay, so that was the lesson, and I will see you guys in a month. Okay, thank you.
Okay.
Bye guys. Bye bye.
Yeah, thank you.